Now, let's discuss what the leading entry of a row is. Now, in any non-zero row of a matrix, the first non-zero entry is called the leading entry of that row. It is the leading entry. So, what this basically means is that the zeros before the leading entry of that row are named as the leading zero entries of that row. So what this basically means is that if you have, for example, let's say a matrix here, and let's say that that matrix is, uh, say this matrix here, uh, say this matrix here. Now this is a this is a non-zero row. Now the first non-zero entry, which is this 2 here, is the leading entry. This is the leading entry. And the zeros before the leading entry of a row are named as the leading zeros, the leading zero entries of that row. So this zero here is the leading zero entry of this row. Sorry, leading zero entry. Now, in the second row here, this 1 is the leading entry and these two zeros are the leading zero entries. Now, what is the echelon form of a matrix? So let's have a matrix A, which is of the order m cross n, and it is in row echelon form if the first condition is if each successive non-zero row, the number of zeros before the leading entry is greater than the number of such zeros in the preceding row. Which this really means is, like, take this matrix here again. The number of leading zero entries in the second row is greater than the number of leading zeros in the first entry, and similarly in the third row, the number of leading zeros is greater than that in the second row. So this is the first requirement of the row echelon form, that the number of leading zero entries in each successive row must be greater than the one preceding it. Now, the second and third conditions of the row echelon form is that every non-zero row in A precedes every zero row. What this really means is that the non-zero rows in a matrix must always come before the zero row. The zero row, the row that has all zeros in it, must come at the end of the matrix. And the third condition for the row echelon form is that the first non-zero entry or the leading entry, as we have discussed earlier, like in this here, this number 2 here is the leading entry of this row. The first non-zero entry in each row is 1. That is the third condition for the row echelon form. Now, see this example here. Now, you can see that the very first condition of the row echelon form was that each successive non-zero row, the number of leading zeros must be greater in each successive row. Now, see here. There is one non-zero, there is one leading zero entry here, there are two leading zero entries, and there are four leading zero entries here. So that is the first condition fulfilled. Now in every non-zero row, in A precedes every zero row. The non-zero row is this last row here, and since it is in the end, this is the second condition fulfilled, and the last condition is that the first non-zero entry in each row is 1. This is the leading entry of this row and it is 1, and this is the leading entry in this row and it is 1 as well. And this is just a zero row, so we do not consider it. Hence, this is in row echelon form. See this example here. These are, you can see that the leading entry here is 1. So, and the leading entry here is 1 as well. So the second condition is fulfilled. The third condition here is that the third condition here is fulfilled. The second condition is that the zero row must be at the end, and that is indeed the case here as well. But remember the first condition. The first condition said that the number of leading zeros in a row must be greater as the number of rows progresses. But as you can see here, there are two leading zero entries in the first row and one leading zero entry in the second row. So the first condition is the first condition is not fulfilled. Hence, it is a in non-echelon form. So, if you interchange the second row and the first row in this example, then it will be in echelon form.